Watch chilled meat cross a maze of machines and emerge as millions of precisely matched sausages. Production begins at the chilled receiving bay. Workers check each incoming lot and move it into the cold side of the plant. Cooler meat stays firmer during cutting, while refrigeration helps slow microbial growth. Sealed totes create traceability. Each batch can be followed through processing and into finished cartons, allowing affected production to be isolated if a later check fails. Notice the one-way flow toward preparation. Plant layouts reduce unnecessary crossing among raw material, cooked product, workers, and packaging. Before grinding, workers inspect and trim the meat, remove unsuitable pieces, and take samples required by the plant's food safety plan. A grinder cannot correct material that is already outside specification. Belts, tables, tools, and bins have smooth, washable surfaces. Hygiene depends on clean equipment, controlled temperatures, worker practices, and separated process zones. Once cleared, the trim material moves directly to batching, limiting its time in the preparation room. At the scales, food production starts to resemble engineering. Meat, fat, ice, seasonings, and any permitted functional ingredients are measured against a controlled formula. Small errors can change flavor, texture, water retention, and the way the sausage behaves during cooking. The ice is more than added water. Grinding and mixing create friction and heat. Ice helps control it while the ingredients disperse. Repeatable inputs are necessary for repeatable output. Only after the batch is confirmed does the cart move on. From this point, every machine is handling one defined production lot. The grinder reduces irregular pieces into particles of controlled size. That creates a mixture the next machine can process evenly. Coarser grinding can also produce less heat than forcing the meat through a very fine plate in one pass. Behind the guard, a rotating feed system pushes material toward a perforated plate while a knife cuts it at the face. The plate controls particle size. Uneven strands at the outlet can signal a feed problem, temperature change, or worn cutting parts. A sample check confirms that the grind is ready before the batch advances. Now the measured ingredients enter the mixer. Ice and seasoning must be distributed through the entire batch, not concentrated in pockets. As mixing continues, salt and mechanical action help extract meat proteins. Those proteins contribute to the sticky matrix that holds water and fat in the finished sausage. The lid closes before the high-power cycle begins. That interlock protects workers from moving components. Inside, paddles fold the mixture repeatedly. In a vacuum mixer, removing some of the trapped air can reduce voids and help create a denser, more uniform fill. Too little mixing produces weak binding and uneven seasoning. Excessive time or heat can damage texture. Operators follow a controlled sequence and monitor the batch rather than judging only by the clock. At discharge, the change is obvious. Separate ingredients have become one cohesive sausage mixture. A small texture sample provides a final check for bind, moisture, and uniformity. The covered tote then moves to stuffing, protecting the mixture while keeping the production lot together. The casing begins as a long, collapsed sleeve on a reel. It is threaded onto the stuffing horn, aligned and placed under controlled tension. Casing type depends on the product. Industrial sausages may use natural casings or manufactured collagen and cellulose systems with different strength, permeability, and handling characteristics. The horn, casing, filling pressure, and line setup determine diameter. Too little fill creates wrinkles, too much risks splits. The operator checks alignment before multiple lanes start together. Now the pump forces the mixture through each horn. The casing expands into a continuous rope, while the line controls its speed. In the close view, A smooth surface and constant diameter show that filling pressure and casing tension are working together. Scaling up does not mean making one enormous sausage. It means running several controlled lanes in parallel. 4 ropes can leave the stuffers together, multiplying output while keeping each strand within the same specification. From here, the ropes move immediately into the linking system. The linker converts a continuous rope into individual portions. Its rotating mechanism pinches and twists at regular intervals, creating the repeating pattern between links. Timing is critical. The casing speed and linker cycle must stay synchronized, or length will drift. Workers or sensors check the chain as it crosses the conveyor. Consistent length helps control pack weight, cooking behavior, and the number of links in each tray. Next, the chains are transferred onto rods and tall mobile racks. Each loop must hang without tearing, and the spacing between rows must leave a path for circulating air and smoke. Pack a rack too tightly, and its center may process differently from its edges. Soon, hundreds of pale links wait for the same chamber cycle. Crossing the smokehouse threshold begins a controlled sequence of heat, humidity, airflow, and time. The chamber door closes and a program sequence begins. Surface drying, smoke application, heating, and cooking. Fans circulate conditioned air around every row, which is why rack spacing mattered earlier. Smoke builds aroma, flavor, and color, but safety depends on a validated cooking process. The amber surface cannot prove what happened at the center. A temperature probe checks the process before release. The plant documents critical operating factors before the rack leaves the chamber. Hot sausages now enter the cooling stage. Water sprays begin removing heat, leaving beads across the casing, and chilled air continues the temperature drop through the dense rack. Cooling is a food safety control. Slow passage through warm temperature ranges can allow surviving spore-forming bacteria to grow. A validated stabilization schedule controls the temperature drop. Its limits depend on formulation and process. A sample temperature check confirms progress before the racks leave the cooling corridor. The links are now firm enough for handling and ready for final inspection. In the quality control room, workers compare the cook links under consistent lighting. They look for uniform color, diameter, intact casing, and surface defects. Instruments turn those judgments into measurements. Color variation can reveal uneven smoke or airflow. Diameter drift may point to casing tension or stuffing pressure. Surface damage can cause leakage. These checks connect the result to earlier stages. Approved links move onward. Anything outside specification is separated for evaluation, rather than allowed to disappear into the packaging stream. The packaging line groups a fixed number of links and positions them in trays. Flexible film is laid over each group, and the sealing station removes air and closes the package. Tight film protects the product and makes leaks easier to detect. Vacuum packaging can slow oxygen-dependent quality changes, but refrigeration, sanitation, processing, and package integrity still work together. When the sealed packs exit, the sausage has reached its familiar retail form. The plant is not finished checking it. Every pack crosses an inline check weigher. Its measurement can identify a package outside the program weight range and divert it from the main stream. Next comes the metal detection tunnel. A suspect pack is automatically pushed into a secured reject lane. That rejection is deliberate. High-speed production needs a physical separation between accepted and rejected product. An alarm alone would be too easy to miss. The approved stream continues only after both checks. Flat corrugated board is opened into cartons, and sealed packs are counted into each case. Mechanical guides fold the flaps and close the box, while the line maintains spacing. The carton protects retail packs, links them to a production lot, and gives the warehouse a standard unit to move. Readable labels are hidden in this reconstruction. Real production requires coding and traceability information. A worker checks alignment and case count before the cartons enter the palletizing cell. The robot follows an interlocking pattern that keeps the load stable. From above, each layer crosses the one below, like bricks in a wall. Once the final layer is placed, stretch film binds the cartons into a single handling unit. A pallet identification step connects that load to the recorded batches inside it. The wrapped pallet can now leave the production floor without individual boxes shifting or losing their identity. Finished pallets enter refrigerated storage in lanes for inventory rotation and order picking. Packaging cannot compensate for poor storage temperature. An electric forklift carries the pallet into a refrigerated trailer. The truck door closes, ending a process that began across the factory. This simple-looking sausage required linked controls, traceable receiving, cold handling, measured formulation, grinding, protein extraction, precise stuffing, validated cooking and cooling, inspection, packaging, and automated rejection. The factory succeeds by repeating that chain consistently, batch after batch, at enormous scale.